Hi students, hope all of you are fine. In this lecture, I will discuss about a new method of solving ODE, ordinary differential equation. This method is known as Runge-Kutta method, RK method. And sometimes they will say RK method of order 4. That means this method which I am going to discuss. Okay. So, in the previous classes we have seen Euler's method, modified Euler's method. This is also another method. This is very important method, and you can expect a question in your semester exam. Okay, so first of all I will try to discuss why they are saying order 4. Okay, so I will try to give you an idea. So let's get started. So order 4 they are telling. RK method of order 4. 4 means basically the power of is h. H of, I hope all of you know Taylor series. Okay. The power of h will be your order. Suppose if I write h to the power r, then r is the order. So in this case the r is 4. Okay. So let's see, I am just within 1 minute I'll try to give an idea of Taylor series. I hope you all know, but still see, yx is equal to, basically the formula is yx is equal to y0 plus x minus x0 y0 dash x minus x0 square by 2 factorial y double derivative at the point x0. Similarly, it continues, right? So now instead of x, if I put x0 plus h, x0 is the initial point, right? And if you move further in your right side, there is x0 plus h. Okay, so x0 plus h, if you put instead of x, you will get this formula. So x0 plus h, yx0 plus h is equal to y0. So instead of x minus x0, you can write x minus x0 is basically h, right? So you can write h. So replace all this x minus x0 by h. So here you will get y0 plus h y0 dash, then h square by 2 factorial y double dash 0, like way it will continue. So for this method we are considering up till h4 by 4. 1, 2, 3, 4, 5. Okay, 5 terms, and last power is h4. So that's why they are telling order 4. We are not including the other terms, but they will remain. Okay, so this is basically RK method of order 4. That's why they are selling order 4. So I will not going to derive the formula, but remember one thing, that Taylor series is the mother of all the formulas of RK method. Okay, so here another thing you just remember, in the previous classes we have discussed Euler's method and modified Euler's method. Sometimes in the exam they can say like this, RK method of order 1. RK method of order 1 is basically Euler's method, and RK method of order 2 is basically your modified Euler's method. Okay, so remember this thing. That means 1 means we are considering only this much first for Euler's method, and we are not taking the other terms. So you can map with the formulas there of Euler's method. You will see that it is basically RK method of different orders. Okay, so now let's try to discuss this RK method. So I will be taking help of a problem so that it will be better for you to understand. Okay, so let's get started with the problem. So they are saying, using RK method of order 4, that is RK4, find y at the point 0.1, at the point 0.2, at the point 0.3, given that your OD is dy dx xy plus y square. Okay, dy dx is equal to xy plus y square, and they have given you the initial values of y. That means y0 is equal to 1. That means at the point 0, your y value is 1. That means your x0 is 0 and y0 is 1. Fine. This is your problem. So in this video, I will solve only this. I will solve this y 0.1. Your task will be to find y 0.2 and y 0.3 at your home. Okay. I will send you the answers. And in the next video, I will be evaluating a second part of this problem, which I haven't written here. Okay, so please do watch the next video, because with the help of another method, we will be solving the second part. That's why I haven't included that part here. Okay, so let's get started. So here, what you need to do here is, they are saying first approximate value of y1 is equal to y0 plus k. y0 you know, k you don't know. Okay, then y1 is basically, can you tell me what is y1? y1 is just the next value of y. Next value is y, means this is y0, right? Y suffix 0. So y0 is basically 1. Next value is how much? It will be 0 plus h. So you need to know h. So if you carefully notice here, the difference is 0.1, then 0.2, 0.3, then x minus x0, that's h, difference of x values is basically how much? You can predict it's basically 1, is equal to 0.1. So h is basically your 0.1. So your y1 will be the y value at the point x1. x1 means how much? x0 plus h. That's why it's written y0. And it will be added up with some other values. And here it will be written k. So I will be discussing what is the value of k. What is k basically? So this is your main formula. And k is basically sum of other k's. The formula is 1 by 6 k1 plus 2k2 plus 2k3 plus k4. Okay, so up to this point you know what is k. K is basically this. But you don't know what is k1, k2, k3 and k4. Okay, so k1 is basically this. K2 is basically this, k3 is basically this, k4 is basically this. Okay, so before discussing this, I just want to discuss a small trick how to remember this formula. See, you just remember VV 1221. VV 1221. See, VV by VI is 6. Right? So VV by 6. And the multipliers 1, 2, 2, 1. Okay, so VV 1221. This will give the value of K. Okay, and just now, let's remember what is K. K is basically HF. All K, this Ks, this K1, K2, K3 and K4 is basically HF. Okay, H is constant, right? This 0.1. F will be different depending on the values of X and Y's. So for K1, my X value is X0 and Y value is Y0. Remember this. Okay, since we are calculating Y1, that's why it is X0 and Y0. If I have been calculating Y2, then it should be X1, Y1. If it is Y3, then it should be X2, Y2, like that way. Just increase the index by 1, plus 1. Okay, so this is your K1. And K2 is basically HF at the point X0 plus H by 2 and Y0 plus K1 by 2. Okay, so X0 plus H by 2. Remember this, and Y0 plus K1 by 2. So I will be not deriving these equations. Okay, but remember one thing, they will come from the Taylor series. Okay, and lastly, this K3 is basically same thing, just replace this K1 by K2. Okay, K1 you have calculated from the previous step and just apply it here. In this step you have calculated K2. Now just apply this K2 here. So you'll get K3. Now pick this K3 and put it here. You will get K4. So for this case, for this H4, it is HF x0 plus H, y0 plus K3. Done. Finish. Okay. So you can do one thing, just remember the multipliers. First, for K1 is 1, K2 is 1.5, K3 is 1.5 and K4 is 1. How? See, so first remember 1, 1.5, 1.5, 1. Okay, so here see, here the multipliers is how much? In this case, is 1 basically. Multipliers of x and y or k you can say. For in this case, you see the multipliers is basically 1 plus half. So 1 plus half is how much? Is 1.5. And similarly for this case also. Here also 1.5, 1 plus half, 1 plus half, so 1.5. Here the multipliers will be 1. So 1, 1.5, 1.5, 1. You can remember like this. Okay. 1 means 1.5, again I am repeating, is basically x0 multiplied is 1 and half of this h. Okay. Half is the multiplier of h. Similarly, it is same for this part also. So no need to remember. You can remember just only 1. Okay. This is basically your formula for solving any ODE using RK method of order 4. Fine. So for this problem, what I will recommend is, as a step 1, just try to construct a table. Okay. So with the help of a table, we will be calculating. First task is to calculate this K1, K2, K3, K4. Okay. This is your first step. Second step is to calculate this K with the help of this K1, K2, K3 and K4. Last step will be use this K here and you will calculate Y1. Y1 is basically your Y 0.1. Done. And this is basically your Y2 and this is basically your Y3. Like that way it will proceed. Okay. So step 1 is, I will recommend to construct a table. So let's see what is there in the table. Here the table is consists of 4 columns: X, Y, F, HF. Remember what is F? F is basically this XY plus Y square. This is dy dx is basically your F. Remember. Now, first of all, this is X. X0 you know. What is X0? X0 is basically 0 and Y0 is basically 1. So write these two X values, X and Y values here. Then find the function value at these points, X and X0, Y0. So if X0, Y0 is basically, if you put X0 is equal to 0 here and 1 in place of Y, then it is 0 into 1, so it's 0, plus 1 square, so it's 1. So basically your Fx0, Y0 is basically your 1. Done. Now you need to calculate HF. Okay, so H is how much? H is 0.1. H is 0.1 into this F. F you have just now calculated. So 0.1 into 1 is how much? Is 0.1. So done. 0.1 into 1 is K1 is 0.1. So K1 you have calculated it. Okay. Next step is to calculate K2. Next task will be to calculate K2. So for that, to calculate K2, you need this x0 plus h by 2 and y0 plus k1 by 2. Okay, these two x values you need, x and y values you need to know. So calculate this first. So x0 plus h by 2 is how much? x0 is 0. H by 2 is how much? 0.1 by 2. So it's basically 0.05. Done. Y0 is how much? Is 1 plus k1 is how much? K1 you have just now calculated, right? So it's 0.1. So 0.1 by 2 is 0.05 plus 1. So 1.05. Done. So you have calculated x values and y values. Okay. Then with the help of this x and y value, just calculate the function value at that point. So basically it will come 1.155. That means I am asking you to put 0.05 in place of x and 1.05 in place of y. Then you will get 1.155. Okay. See, now you need to calculate HF. HF is how much? 0.1 into this. So 0.1 into this means 0.1155. Done. Just check it. If I made any mistake, then just make the correction. Now, lastly, next part is to calculate K3. Okay, to calculate K3, you need x0 plus h by 2 and y0 plus k2 by 2. So, x0 plus h by 2 is basically this one, same thing. Instead of k1, just write k2. K2 is just now calculated, 0.1155. So, put this 0.115 here and you will get 1.0577. This is your y value. And if you pick this x and y value and find the value of f at that point, you will get 1.172. Same thing, you need to put 0.05 in place of x and 1.0577 in place of y's. Okay, you will get 1.172, and if you multiply with h, you will get 0.1172. This is basically your K3. Lastly, you need to calculate K4. K4 is basically x0 plus h. You need to know x0 plus h and y0 plus K3. So x0 plus h is 0.1, y0 plus K3 is 1 plus this K3. So 1.1172, and if you put this x and y values in the function, you will get 1.3598. Same thing. And if you multiply with h, you will get HF, that is basically your K4. So 0.13598. So this part is over. So step 1 is over. Step 1 is to construct this table to find the value of K1, K2, K3 and K4. Done. Next step 2 will be to calculate K. Okay, so K is basically, step 2 is, K is basically 1 by 6 of this. So K1 is how much? It is 0.1. K2 is how much? 0.1155. K3 is how much? 0.1172. K4 is how much? 0.13598. So 0.1 into 2 into 0.1155, that is basically your K2, plus 2 into 0.1172, that is basically your K3, plus K4, 0.13598. Done. So if you solve it, you will get 0.11687. You can approximate to 0.1169. So second step is over. Second step is to calculate y. Now step 3 is to put this k value in this equation. y1 is equal to y0 plus k. y0 is how much? Is 1. So y0 is how much? It is basically 1, and k you have just now calculated in step 2. So put this value, you will get 1.1169. Done. Remember, this is y1. y1 is basically y 0.1, and y1 is basically, x0, y at the point x0 plus h. x0 is how much? 0 plus h. H is how much? 0.1. So 0 plus 0.1 is how much? 0.1. Okay, same thing. So your y 0.1 is 1.1169. So this part you have calculated. Done. This is the total method. So first of all, you need to find the values of K1, K2, K3 and K4. Second step is to calculate K. Last step is to calculate Y1. Or if it is required, you need to calculate Y2. If it is required, you need to calculate Y3. So Y2 and Y3, that is Y at the point 0.2 and Y at the point 0.3, I will suggest you to do it at your home and just check, verify with my result. Okay, so similarly you can calculate y2 is basically y at the point 0.1. It is y1 plus k. So just increment this in suffixes by 1. Okay, just the whole formula will remain the same. Only this formula will remain the same, of course. But here, instead of 0, write 1. Remember, write 1. So x1 you need to put. x1 is how much? x1 is basically 0.1. x0 is 0. x1 is how much? 0.1. So instead of x0, write x1 and other things will remain the same. Okay, so if you do that, first of all you will get k as 0.1605, and if you add it up with y1, you will get 1.2773. Remember, this y1 is basically what you have calculated here. 1.1169 is basically your y1. If you add it up, you will get 1.2773. Similarly, for y3 is basically y0.3 is y2 plus k. y2 you have calculated in this step. So use that, and k for this case will be 0.2267. Just verify it. You will get y3 as 1.504. So this is your answer. This one, and this one. These three is the solution of this problem. So remember one thing, for y3, this x zeros will be, guess what? It should be x2, right? So remember this, only the k1s, k2 and k3 will change, and this will change, okay? And the other normal, the second step, that means to find the value of k, basically this formula will not change, okay? So I hope you have understood this process. Archimedes method is a very easy process, and you can see in this method, this is a universal formula, general formula. You only need to know the f values, the function values. Okay, you need not to deal with this higher order derivatives, right? So this make this method advantageous. Okay, so I hope you have understood. If you have any doubt, you can call me, WhatsApp me. Okay, and do solve the other two y values, that is y2 and y3. Okay, and just check it. Okay, so you can directly use this formula also without going into this tabular format. You can directly do that, but the probability of committing mistakes may increase. Okay, so I will suggest to follow a tabular format. Okay, so I hope you have understood. Stay safe. Thank you very much.